pod, like we saw something related to the deployments, what a deployment is actually, and then so what is the basic what is the basic requirements like? So any AML files like Kubernetes AML files, they follow a specific format. Like so, the format is something like this. So you have like API version where you specify the version of the API like which you would like to use, and then the kind. So if you want to create like deployment, so the kind will be like the type of the resource like you would like to create. Like if you want to create deployment, it is deployment. If it is pod, so you can specify pod services and all that stuff. Okay. So along with that, like we also have something called as metadata. So metadata is nothing but like it has labels and then name. Usually like these labels are used for identifying or connecting multiple resource types. So for example, like if we are actually creating, so if you are creating a service, like so service or volume, and you want to attach this particular volume to to one of these pods, okay? So how you'll actually combine these two. So basically like using this labels. So we will have this label which is present over here. And this particular label is used in the other file. Like so basically like selector and then match label. Like so you'll specify the selector that matches this label. And finally, like the most important part of this particular resource file like is the spec. Okay. So what the spec actually contains is like, so it is basically like all the steps like which you would like to achieve. So for example, like the main purpose of the deployment is to create like pods, and then these pods are supposed to be replicated. Like you would like to create like multiple replicas, like it can be like 3, 4 replicas or something like that, right? Usually like all these components like deployments, and then there are other components like replica sets, and then few more components like which actually use something called as pod template. Okay, so the pod template is nothing but like, so you have this pod specification, right? So except these two, like, this API version and the kind, so you'll actually have the same template. Like so you'll just have the same template of a pod that is described inside this spec. Okay, so for that, like what we need to do is like, so inside the spec, like we have something called as like, so this is the spec, like, and the spec might actually change for each of these types. Like, so for resources, like services, it might have like a separate spec. For deployments, it might have a separate spec. For pod, like you might have like separate spec. So for pod, we have the basic spec, like it is something like the containers and then which image is supposed to be used and all that stuff. Whereas coming to the deployment, so the spec is quite different. Like, so it has like few required fields. So one is like the selector, and the other one is like replicas, like how many replicas you would like to create. And the other one is like template. So what this template is actually is, so this is actually the pod template. So the pod template is nothing but like, so in this deployment, like what type of pod you would like to create. So I would like to create an Nginx pod. Okay, so what I'll do, so again, this is a pod template, right? So the pod template, we should actually replicate the same thing. Like again, this pod template will have metadata, and then it will in turn have like spec, all these things, right? So you can just ignore this API version and kind. Apart from that, like you need to provide all this information, mandatory information in the pod template, like which is metadata and then spec. So here, like I'm doing the same thing, metadata. So for this metadata, like I just gave this name as like in the next name or something like that. And then the labels, like for this pod template, the labels I'm providing is like app in the next one. Okay, so this is the label key and this is the value, like label value. So I'm just providing these labels. And as I mentioned, like pod template again has like metadata and spec, right? So inside the spec, like you are providing all this container related information, like Nginx container and which version of this Nginx you would like to use and ports. Okay. So in order to tie this particular pod template to this deployment, so as I mentioned, like, so usually like these labels, like the labels that were provided in the metadata, they're basically used for tying different things, different resource types, right? So I want to uh, relate this particular pod template to my deployment. So that is where like the selector actually comes into picture. So the selector, in the selector, like I'm just specifying like match labels, like so which label it should actually match. So I'm looking for in the next one. So this particular label and this label, it should actually match. Okay. So this is the basic deployment template. Okay. So you can create like, so you can apply these commands like kubectl apply -f deployments. So you can actually see kubectl get pods. So since I specified like 5 replicas, so I'm just doing like I'm getting like 5 instances which are actually running. Okay. So another important thing, like so yesterday, like when we are actually talking, so there is something I'm just going to show you. So I was mentioning like deployment, it actually manages a replica set, and replica set in turn manages like a pod. So now we'll see like what this replica set is actually. Okay, so the replica set is an important component of Kubernetes, so which is actually helping us in managing these replicas. Okay, so when you specify like 5 replicas, so this is the one like which is actually taking care of this replication. Okay, so this is actually responsible for creating a replica set. Okay, now let's see. So the replica set that got created, like I didn't actually create any replica set, right? So, but when we apply this deployment, so it automatically creates a replica set. That is because like the deployment, it manages a replica set and which in turn will create a pod. Right? So let's see replica set. So it is kubectl get replica. So sometimes like you can also use shortcuts like kubectl get rs. It gives the same information. So this is the replica set like, so which was actually created by this Nginx deployment. Okay. So we didn't actually create it manually, but Nginx is actually creating it. So let's see what this replica set actually contains. kubectl describe rs. So you can use the shortcut rs or the replica set here. Like, so if we see this particular replica set, so it has like a name and then it has its own labels. Okay. And it is just providing this information like, so when this pod was actually the replica set controller, so this replica set controller is actually part of the master node. Okay. So which is actually helping us in creating these replicas. Okay. So how does it actually, like this replica set controller, it in turn will make use of this data stored in the etcd for identifying the actual state and then the current state. Okay, so the actual state, like desired state, is 5 replicas, right? I would like to have like 5 replicas always. Like, so let's say like if I kill a pod, the actual state is something like 4, right? So immediately like the replica set controller, like it triggers and then so it actually makes sure that like, so it creates another replica. Okay, so to maintain the desired state. So this is about replica set. Okay, so you can see some of these details about the replica set. Okay, so apart from this deployment internally creating these replica sets, so we can also create replica sets manually. Like, so just like the deployment template, like we can also create like replica sets. Okay, and even the replica set is actually used for creating these pods. Like, so the replica set, even with replica set, like you'll have the same similar kind of template. And then you'll have like the container. So which container you would like to create and all this stuff. Like, okay. So one difference like I would like to show you before actually starting the replica set is, so for example, here if you see kubectl pods. So it was created almost like 4 minutes back. And then this particular image, kubectl pod. So if you see this particular pod, okay. So this is actually using this image. So it is using like Nginx 13.2, right? So let's just keep it in mind. Like, so I'm using like Nginx 13.2, and then these are my pods. Okay, I'll just keep a note of them. So these are the pod names, right? So the pods that got created. So now what I'll try to do is, so I'll simply change this particular deployment file. So from 13.2, I'm just trying to increment it to 14.2. Okay, so I want to change the Nginx version like which I'm using. Okay, so I'll do kubectl apply -f deployments.aml. Okay, so you can actually see the configured. Now let's see get pods. Okay, so you can see like the old pods, they are getting terminated and then the new pods are getting created. Okay, some of them are in pending state and some are in terminated state and terminating, and then some are in running state. Okay, so you can just see this. So it's in the process of deleting. So now if you see, so now if you see like all these new pods are actually created, and if you copy the content, okay, let's see, compare this to. So you can actually see, so there is no match between these names. Okay, so you can see like, so this is the pod name which I gave, like the deployment name which I gave, right? So and the next deployment, and then so it is actually trying to append some hash. Okay, so when I just change this particular 13, the image Nginx version from 13.2 to 14.2, so all these old pods like they got deleted, and then all these new pods they were actually created, right? So just keep in mind that whenever like new pods are actually getting created, so it doesn't actually persist the name. So it is actually generating a random hash at the end. It's the format is something like deployment name hyphen like random hash. Okay. So and there is no match, like so the name is not actually getting persisted over here. Okay. Just keep it in mind. So we'll see like the differences between. So this actually helps us in another concept called as like stateful sets. Okay. So, but just keep this in mind. And another thing like which you would like to understand here is like, so whenever I'm changing this particular Nginx image version or something like that, okay. So, and then when I did like apply, so new version of the pods actually got created, right? So now let's see replica sets, okay. So let's try to create a replica set now. So API. I just wanted, so if you have like Visual Studio Code, so you can install a small plugin, like, so there is a plugin for Kubernetes, so which will actually help you with all these things, like, so basically, so extensions, like you can actually search for Kubernetes. So you can just install like Kubernetes support. So this helps me. This is helping me with all this autocomplete and all that stuff. Okay. So for example, like so if I wanted to create a replica set, so what I'll do is like, so after installing the plugin, I'll just do kind. Okay. So my kind, which one I wanted to create? I want to create replica set. So when you type like few words, so here like I'm not actually getting for replicas. Right? Okay, for replica set, I'm not actually getting, but for services and other types, like you can actually see. So this doesn't autofill. Like it's just it helps me with the syntax. Okay, that is the only advantage. But replica set, like let me actually create it. So API version, so this is the version app/v1. And after that, like I'm supposed to create like metadata. So when I'm creating metadata, so I can specify name. So name of my replicas is like nginx rs, and then labels. So labels is an array. So labels, so it's just like key value pairs app. So it is like I just wanted to give the same label. So after metadata, like we have something called a spec, which is actually important. So in the spec, like the first thing, like important thing is like selector. So I wanted to use like match label. So even I am very bad at like remembering this syntax, just trying to remember match label. So which one I wanted to? So I wanted to use this app and the next part. Okay. So maybe like I'll try to delete this. Yeah. So after selector, so I will have like template. So inside the same template, like this is again like pod template, right? So I'll have metadata. So in metadata, I'll have label, the app underscore. It should actually match my selector label. After that, like we'll have metadata again, like this is the pod template, right? So pod template again will have spec. So the name of the container, like nginx, and then so image nginx. So I wanted to use this 14 point. I'll copy this. No. So I'll use 13.2. So this is my replica set. Like another important thing, like how many replicas I wanted to create, like replicas. So I want to create like 5 replicas, 5 replicas. Okay. So this is actually complying failed server. It failed to create type. Template metadata labels app nginx pod. Field not declared in schema. Okay, let's see. So kubectl get deployments. I'll delete like any existing deployments so that like you can actually understand the difference. Kubectl delete deployment. So this is the deployment. So when you delete the deployment, it internally deletes all this, all the replica sets and then all the pods that were created. So for example, like kubectl get rs. So nothing. Kubectl get pods. So you'll not have any pods. Okay. Now let me apply. Let me create this replica set. Apply minus f replica set. Okay. Unknown field match labels. Selectors. Selector. Okay. It is. It should be like match labels. L should be capital. Okay. kubectl apply minus f replica set. So you can see that replica set is actually created. Let's see like kubectl get rs. So you can see like one replica set is actually created and it has like desired state and then the current state. Kubectl get pods. Okay. So you can see like the pods are also created. Okay. So when you can actually see that the deployment is also having the similar kind of syntax, whereas like the replica set is also having similar kind of syntax. Like, so if you see like the deployment and then you have metadata spec and then match labels, replicas, template, like node template, pod template. So even you have something kind is replica set and then you have the same name labels and all the stuff, replicas, selectors, and then templates. So even this is actually creating like pods. So then what is the difference between these deployments and then the replica set actually? So as I mentioned, like the deployment is just like it is actually on top of, it is a layer on top of this particular replica set. Like, so it is actually managing the replica set and then with replica set is actually managing these pods, right? So the difference between this deployment and then replica set here is, so for example, like in the deployment, like when I'm changing this particular image from 13.2 to 14.2, so it is actually creating like new, so the deployment is actually creating new pods, like it is terminating all those existing pods and then it started creating like new pods, right? But here, let's see, like, so what is actually happening? So I'll just provide like in the next, I'm just updating this replica set image name to 4.1. I'm still not applying, but I'll just copy this content. Okay. So now I'll try to apply this thing like kubectl apply minus f, and then my replica, my file name is replica set. So already replica set I updated, I applied, but after applying, like I made a small change in this particular pod template. Like, so I'm just using this in the next image. Okay. So again, like after making this change, so I'm simply applying, reapplying this change, like replica set file change. Okay. So you can see like this is actually configured. Okay. Now let's see pods. So you can see that they are still pointing to this thing, like, okay, so 9K LV4, 9XHVX, and then all these things, like, and these were created like almost 2 minutes back. Like, so this is the initial version, not the current one. So you can see like nothing is happening, like they're not getting terminated or they're not getting deleted, right? So, and if I do like, if I see describe a pod, kubectl describe pod. So here, like you can actually see the image version. So it is still pointing to Nginx 13.2. Okay, so even though like after making the change, so I made the change to 14, image 1.14.2, but still like even after reapplying this replica set, so it is still pointing to 13.2, right? If you want, like again, I can actually apply this. So you can see like nothing is changed. So that is the main difference between like deployments and then the replica sets. So basically in the replica set, like any changes which you make in the pod, so they don't actually reflect. Okay, so you need to delete that particular replica set and then you need to recreate it. Okay, for any changes related to this pod template. Okay. So whereas like with the deployment, so if you make any changes to the spot template, so even that will be reflected when you apply changes for a deployment. Okay. So any questions still now? So no questions?
No, not from my.
Okay. So you got the concept between like deployments and then replica sets and the pods, right? So basically like pod is a basic unit. Like okay. So kubectl, I'll clean up my resources. Delete -f replicas. Okay, so there are no pods and nothing left. Yeah. So this is the main difference between like so pods are like basic building blocks which are encapsulating like and these containers. So and on top of this, like we have something called as like replica sets and then the deployments. So ideally, like even in the production environment, like so we actually go with these deployments. So you'll not actually create pods using replica set. So that is because like so replica set, so deployment will actually take care of creating this replica set internally. Okay. Okay. So let me apply this deployment again. So now we'll actually see another important concept related to Kubernetes, so which is actually called as like services. Okay. So services are the basic building blocks. Like so again, like another important concept for the communication. So if you remember, like initially, like when we are actually talking about this particular um, all this information, like so the Kubernetes architecture. So I was actually mentioning like so you have kubelet, so which is actually responsible for communicating with the containers and then the APIs and creating these pods. So if you have like multiple services, like okay, so if you have like multiple pods, so as I mentioned, like so they don't actually have direct communication. So you need something to communicate for establishing the communication. So this is where like the kube proxy it comes into picture. Like the kube proxy, so basically like this is a component of Kubernetes, so which actually is responsible for the networking. Okay, so for the networking to happen, like you need to create like so basic services. Okay, services are the components like which are actually responsible for creating the networking. Okay, and there are like multiple service types. So there are like node port, internal, external, load balancer, and also something called as ingress. Okay, so today, so I'll not jump deep into the services, but so first today let's see like how we can actually establish communication between different deployments. So for this, like what I would like to do is like, so I would like to take a MongoDB deployment and then, so the MongoDB and the MongoDB Express. So these are the ones like which we are actually familiar with. So we played with them during our Docker sessions, right? So even in these sessions, like we'll actually take these things. Like so, we'll take like MongoDB and then the MongoDB Express, Mongo Express. Okay, so for anyone like who actually joined new, like MongoDB is the database. So whereas like Mongo Express is again like a container which was actually provided. Like so, it is a API container, like kind of container. So basically, it is the one like which Node.js. It is actually running Node.js application. So which is communicating with this particular MongoDB, and you'll have like some interface to interact with this particular MongoDB database, like create collections and then create databases, all that stuff. Okay. So this is the one like. So this is the Docker official image for Mongo Express. Okay. So you have MongoDB. I'll also use MongoDB. So this is my MongoDB database. Okay. So this is the actual database. So if we see, like, if you have experience with like MySQL and then MySQL or Postgres, so usually like you'll have this MySQL installed, like in the production environments, like you'll have MySQL installed on some different servers. It might be a production server or stage server or QA database servers, right? So from your local machine, so how we actually interact with this particular MySQL database? So we have something called as like workbench, MySQL workbench. So it is just like a user interface which is used for interacting with the database, MySQL server. Same is the case with SQL Server. Like you have a SQL Server Management Studio using which like we communicate to SQL Server. Okay. So in this case, like Mongo Express, so this can be treated a little bit like, so it can be like a management studio for Mongo. Okay. So it doesn't have like any fancy stuff, like, so it doesn't actually provide all the fancy stuff like these high level studios provide, like I mean, SQL Server Management Studio or Workbench, like MySQL Workbench. But to some extent, like to interact with the MongoDB, so this is actually good, at least for our demo purposes. Like, so this is actually good. So it is actually web-based MongoDB admin interface written in Node.js and then Express. Okay. So initially, like for this particular thing, like so MongoDB, like we need to have few things. Okay. So the MongoDB, like whenever like this is the container, like so if you want to run MongoDB, so we can use like Mongo EBS. Okay. And it has like few environment variables. So for example, like if you see this environment variable, so you need to pass like a username, root username, and then root password. Like, so these are the environment variables. So which are we are actually passing, and they'll be taken by the MongoDB server. Like, so when it is when the server is getting started, so it will use these credentials like to start the server, and we can use these credentials to communicate with MongoDB. Okay, when framing these connection strings and all this stuff. Now let's try to create a deployment like which is actually making use of this MongoDB Express. Okay, so I'll just rename this. So deployments underscore Mongo. So I'll just have it as Mongo. Okay. So the syntax is exactly the same. So I'm just using this API version kind deployment. In metadata, like I wanted to use it as Mongo deployment. Okay. So selector, like I wanted to use MongoDB. So I just want to go with like single replica. So this is because like usually with databases, okay. So if you take like any database, MySQL, SQL Server, or MongoDB. So if you have like multiple, so the main purpose of Kubernetes is like to have like multiple replicas. So for example, like if I have like multiple replicas, okay, so of this MongoDB, what is actually going to happen? So for example, like this is my MongoDB pod 1, and this is my MongoDB pod 2. Okay. So usually, like if you have some knowledge on this SQL, on these databases, like so how these databases actually work. So usually like you have one read write node. Okay. So this is actually a read write node. So read write node in the sense like, so we actually read as well as like write data to this particular node. So if you are actually experienced with SQL Server, like so majority of us like we are actually working on .NET, right? So SQL Server, like we'll have like one big instance of this SQL Server installed. Like so it has like good amount of RAM. Like so one of the SQL Server instances which I saw, like it has almost like 128 GB RAM. Okay. So which I work with, like okay. So it is only a single server. Like on this server, like you'll have like a good amount of hard disk space, and then you'll have like SQL Server installed. Like so, we actually communicate like for writing the data as well as like reading the data. So we communicate with this particular single instance. Like okay, so this is my master node. This can be called as my master node. So usually, like if anyone has experience with like MySQL, so and especially like so I work with like uh, Aurora databases in AWS. Okay, so there with MySQL you have the concept of like master node as well as like replicas. Okay, so these replicas are nothing but like read-only replicas. So these are like replicas. Read read only replicas. So usually, like, so for example, like I'm actually adding an employee. So what happens is, so if you have this type of configuration, like so master node and then read only replicas. So let's assume like in this case, like if I just specify this replica count as 2, what is actually going to happen is, so you'll have like two master nodes. So two read write nodes. So you'll have two read-write nodes. Okay. So if I use exactly the same configuration, replica count as 2 or more than 2. Okay. So usually the problem with this is, so you'll always have like data inconsistency. For example, like if you're trying to write, so if you're trying to write some data, like so you have an employee table. Okay. So you're making a copy of this, you're creating an employee table. So initially the request might actually go to this particular node. Okay, employee table. Okay, so create employee table. So whereas like again, like I actually try to insert some data into this employee table, my next request. Okay, so let's assume that like, so using these replicas, these are actually load balanced, right? So if you actually try to create like, so since it is load balanced, like you'll have some kind of service over here, like load balanced service, and the request to this pod or this pod is actually determined by this particular service. Okay, so now after creating this employee, like the create employee, it got inserted, like it got created in this particular node. So now if I'm trying to insert a record like employee record, I don't know like whether the request might actually go to this particular node or it might actually go to this particular node, since both of them are like read write nodes. Okay, so if it goes to this, it is fine, but if it is actually going to this particular node, so obviously like it doesn't actually find an employee table created over here, right? So it will be a problem. So if the same is the case, like, so if I'm actually trying to read this employee record, okay, so the request might actually go to this node or this node. Okay, so this might have some data, this might have some data, and it will be a big issue, right? So that is the problem with all these databases like SQL Server, all SQL Server, MySQL, and then these MongoDB databases. So this is not the case with like some of these databases like Elasticsearch or other databases. Okay, so that is because like, so you'll have like a master node, you'll have the concept of master node and then other nodes. Okay, so where the data is actually replicated across like multiple nodes and all that stuff, like it's altogether a different concept. But here in this case, so the point to remember is like, so if I create like replicas as 2 over here, the problem would be like I will have like inconsistent data, and I cannot actually guarantee that like my MongoDB server will actually start properly. Okay, so that is the reason why like I'm actually going with one replica for my MongoDB server. So any questions for you?
No problem.
So this is clear, right? So why I'm actually going with one replica?
Yes.
So just to avoid like data inconsistencies. Okay. So these type of databases, like they don't actually support multiple read-write nodes. Okay. So you can have something like one master node, which is like a read-write node, and you can have like multiple read-only replicas. Like you can create like multiple read-only replicas, and the data is actually synchronized between this master node and then these read-only replicas. Okay, so whenever like a request comes, like if it is like a read request, so the request goes to this particular node or this node. Like these are actually load balanced. This actually reduces the load on this read-write node, master node, right? Okay, so that is a different concept altogether. Okay, so the only point to remember here is like, so for databases, like if I wanted to use this deployment, like I should go with like one replica. Okay, so there is another concept called as stateful sets in Kubernetes, so which actually deals with, which can be actually used for configuring this type of configuration. Okay, so it can be used for configuring this kind of setup. Okay, not this one. So this kind of setup, master read-only replicas. So we'll look at it at a later point of time. Okay. Yeah. So now I'm creating like a one replica. And then the metadata name is like MongoDB. And then this should actually match my label. So MongoDB. So after that, like I would like to use these containers like Nginx container. Not Nginx, like MongoDB container. Right? So it is like Mongo. So I'll be using this Mongo. So my name would be like Mongo. I wanted to use the latest version of my MongoDB miss. Okay, and the port that is exposed by MongoDB is 27017, I think. Yeah, usually MongoDB by default it runs on this port like 27017. So I'm just saying like the port that is exposed inside the container is like 27017. Okay, so let me try to apply this deployment. CTL deployments. So I'll delete this deployment cleaner. CTL delete. And I'll apply this MongoDB deployment. Okay, so the deployment is successful. And then let's see kubectl pods, get pods. So I have like one MongoDB pod which is actually running. It started and it is actually running. Okay, by default, like here, I didn't actually specify any username and password. Like, so if I don't actually specify username and password, I think like Mongo will use it. So you can connect to MongoDB without any username and password. Okay, but in case like if I wanted to create a username and password, like okay, so here like we saw like these username and password, like this is actually these keys, like so they're actually provided by like MongoDB container itself, like image itself. Like you can get that information from this particular Docker documentation. So this is the one like I wanted to use like environment. Okay, so in order to provide environment variables, so you can use like env in the name of the environment file, environment. So this is my name, and then value. So value is, so I wanted to use the same value. So this is my root. So another one which I wanted to use is like email. So password. For password, like I'll be using this value. So password, like I wanted to use the same one example. Okay, so let me reapply my MongoDB deployment. Let's see kubectl pods. So you can actually see only once this pod is getting started, like so then only this is actually getting created. Till then, like it is actually in running. Okay, so the new one, it is actually running now. So you can actually see these logs related to this MongoDB. Logs, kubectl logs. So these are the logs from MongoDB cluster. So you can see like I just provided like root user, right? So this is the root user. And it is actually running like MongoDB. Okay. So we have like MongoDB deployment and I have like single pod of this particular MongoDB. Okay. So I'm not actually mapping any volumes over here. Like, so since I'm not actually mapping any volumes, obviously the data gets stored inside this pod. Like, and if you restart this pod, obviously you'll lose all the data. Okay. So we'll see about these volumes at a later point. Like, so for now, let's make sure that like if we recreate this pod, like we'll lose all the data. So this is the MongoDB deployment. Okay. So here, if you see, like we are actually reading all these env files, env values like MongoDB username, password, and all this stuff, like using these roots and then using these env values directly, right? So Kubernetes also provides another option to store to read these environment values from some files called as like config files and then config key files and secret files. Okay. So you can actually create a secret file and then you can store all these key value pairs, like all the data, which all the secrets like which you wanted, like you can just store them in these secrets and you can actually refer them over here. Okay. So we'll just see like the secret example. So I'll create like a secret, not AML. Okay, so kind. So I wanted to use like secret. So you can see like, so it automatically fills these values. So I'm creating a secret. So as I mentioned, like you'll have all these mandatory things: API version, kind, metadata, and then like you have something called as like data over here. Like, so what is the data like? So you need to provide some name for this particular secret. Okay, so I would like to name my secret as MongoDB secret. Okay. So if I wanted to store all my keys like username and passwords, like somewhere in this secret file. Okay. So what I'll try to do is like secret key is username. Just have it as like Mongo-username. And you need to provide like instead of like you cannot actually provide this root directly like the username directly. So it should be like base64 encoded like so the base64 encoded string like how you can actually create like you can actually create this base64 encoded string. You can actually go to some website like generate base64. So this is one way like you can actually generate this intent like this by going to this file. Okay. So Mongo so password, like my password is something like example. So another way, like you can actually create these MongoDB passwords is something like, I mean, these base64 strings is something like this. So you can just use, uh, so the command something like this, echo -n. So this is just a Linux command. So and the password like which I would like to use is example. Okay. Example and then base64. Okay, so this way like it actually gets created. So this particular command like this doesn't actually work in command prompt or PowerShell. So I have like the Git bash like which is actually installed on my machine. Or if you have like any Linux flavors like so you can actually execute these commands like to generate base64 strings. Or else like you can approach online version. Okay. So this is how like we actually store this data like in the secret files. Like you can store all this information in the secret files. And there are like multiple types that are actually provided by SQL, like by Kubernetes, like the secret types. So the most one predominantly used one is like opaque, where you can actually store this data in the key value format. Like, and there are like other formats like Kubernetes.io.base or base or and then so multiple secret types. So I can actually show that thing. So these are like different types which are actually supported. Like, okay, so you can actually create like service token account, like service token account in the sense like, so when you're actually communicate between multiple services, like, okay, so you can actually configure this cloud, like in the cloud, like you can configure this service token accounts, and you can use this service token account, like service account token. Okay. So you have basic auth, and then so we'll see these things like at a later point of time. Like, so we'll do some detail analysis on this. Like, so most of this even I'm not pretty familiar with. But for now, let's go with like this opaque. Okay. So in this opaque, like, so this is how like you provide this data. So now I created my secret file. Like I'm supposed to use this secret file somehow in my MongoDB, right? So in my deployment files. So how I can actually use this is, so just like this, like you can actually use something like this. And instead of values, so you have something called as value from. Okay. So what this value from is actually doing is, so if you see, so it has something called as like value from. So you have, so you can specify like what is the name of this particular, from which, I mean, so from which secret you're actually trying to get this particular value, like, and so something like this. So value from. So I just wanted to refer this from, so secrets, right? So you can actually see, so for the value from, it supports following types, like it is config map key ref, field ref, and then resource field ref, and then secret ref. So we are actually using this secret file, right? So we should actually make use of like secret ref. Secret ref. So so you can get that information from here, like secret key ref. So from the secret key ref, like again, like, so you need to specify, like, so you're specifying, like you're trying to take this env values from the secret keys. Okay. And we need to specify like this, these secret keys, like what is the name and then name. So name in the sense like which secret file I'm planning to make use of. So in my case, like I have this secret file. It is like MongoDB secret. Okay. So this is my secret. And then, so the key, like which key I would like to use. So the key is MongoDB username. Okay. The same way, like even here, like I can actually read the data from this env value. So I'm specifying, like I wanted to read. So this is the name of my env. So for the value, like I'm just specifying, like I would like to take this value from the secret key. Okay. So this secret key, like, so which secret key I would like to take? So I would like to take this value from this particular secret key, like MongoDB secrets. Okay. And what is the key name I would like to use? So I would like to use either this or this, like username or password. Like this is the key name which I'm going to use. So now if I just execute, so you'll see an error. kubectl deployment. Uh, So kubectl. So you can actually see create container configurator. So let me actually describe this. And another interesting thing like you can actually see is like, so basically like what I'm actually doing here, like I just changed all these env values. Like previously, like I have hard coded values over here, but now I just made my change to read them from the secret keys, right? So previous deployment, it was actually successful. Okay. So now when I'm trying to apply this deployment, so you can see like, so this is actually not killed. Like, so this is still in the running phase. And but this is when this was actually tried to create this pod, like when it is actually getting created. So there was an issue like create container configure. Okay. So since there is an error, like it didn't actually delete or stop this original container, like okay, original pod. So until and unless like this is actually in successful state, like so if it is in starting state, so this doesn't actually get deleted. So that is like one of the benefits of Kubernetes. Okay. Now coming back to this particular error, like create container configure. So let's see like what is actually kubectl describe. Okay, so this doesn't even exist. So the reason why like we are actually getting this container configuration error is, so I'm actually specifying like, so which secrets to use. Okay, so but I didn't actually execute this secret file, right? So I didn't actually create this secret file. So if you see secrets kubectl get secrets. So you can see like I have different secrets like identity management secret, I have like interview builder secret, and I have like MongoDB Express secret. So these were actually created almost 21 days and then 21 days back. Okay, so long back, like when I was working on some of these projects, like I created them. So, but this was not actually created now. Okay, so what I should actually do? So initially, like I should apply this secret file. Okay. So now when I do like get secrets, so you can see like, so the MongoDB secret, it was actually created. And now if I apply this deployment, so the old one got deleted and the new one. Okay, so it was in this other phase, like so it was in create configure phase. But once I created this secret, like it got successful, like it got created now. Okay, so this pod is actually running now. So you might actually ask me this. So this is the advantage of secrets. Like, okay, so along with the advantages, like the secrets also have like some disadvantages. Like, so since these secrets are like a base 64, like anyone who has access to kubectl, like so they can actually see all these secrets. Like, get okay. So if anyone has access to these APIs, so Kubernetes APIs, so they'll be able to see all these secrets, right? So for example, I can describe this secret. So you can actually see like, so it was actually 7 bytes. So we can actually use these secrets, and anyone can actually, so who has API access, like they can actually download these secrets and then they can also view these secrets. Okay. So this is one of the disadvantages. Like, so though like you create, so ideally like how this actually helps is like, so basically you'll deployment files and all these files, like what you do is like, so you commit them to your GitHub resources. Whereas these secret files, like you can just apply them once, and then so all the time, like you can actually use these secrets, like you can refer to these secrets in multiple deployments in multiple places. Like, okay. So that is one advantage. The drawback is like, so this is just like a base 64 string, and then anyone who has access to the API of Kubernetes, so they'll be able to access these secrets. Okay. So that is a drawback. So in order to avoid this, like if you feel like I have more sensitive data and I wanted my application to be more secure, so usually like you have multiple alternatives. So you can use things like vaults. So usually a Shikot vault or AWS vault or Azure vault. So vaults are nothing but like these are the items like so softwares like that are actually provided by these cloud providers. So where you actually store this information like any certificates or any key value pairs. And in your code, like you can just refer to these vaults. Like so you can connect to your vault and you can get all this secret related information like any secrets and you can just apply them. So you can avoid secrets in some cases. But if you have like very minimal things like so if you feel like this is not actually a username or password but if it should be like somewhat secret like then you can go with like secrets. Okay. So we created like MongoDB deployment, right? So tomorrow, like we'll create like MongoDB Express deployment, and we'll also create a service. So and establish the connectivity between these MongoDB containers and then the service MongoDB and MongoDB Express. Okay. So any questions till now in today's session? So did I go fast or any questions? So I'll stop it for today. Like I'll just stop the recording.